All right, so next we're going to talk about overdetermined and underdetermined systems of linear equations. So an overdetermined system of linear equations is one in which you have more equations than variables. Okay, so in those situations, really the only way that you can get exactly one solution is if two of those equations are really the same line. And then you can possibly get exactly one solution. A lot of times, though, you get no solution. If you find out that you have, more constraints on your system, and there you have conflicting constraints, and so oftentimes you get no solution. But you can also get infinitely many solutions as well. Now, in an underdetermined system of linear equations, you have fewer equations than variables. And in a situation like this, you really don't have enough information to ever get a unique solution. Okay, so you're either going to get no solution in the case where you have, you know, these equations that are parallel to each other, or you get infinitely many solutions. All right, so let's take a look at, here we have an overdetermined system of linear equations because we have three equations and three unknowns. So we would consider this to be overdetermined. Overdetermined. Okay. And so, but we're just going to approach this the same way that we would, with Gauss-Jordan. Okay, we'll just use Gauss-Jordan to try to solve this system of equations. So I'm just going to create an augmented matrix, just like I have before. So 1, 2, 4, 1, minus 2, 0, and 4, 3, and 12. Okay, there's my augmented matrix. Now, my end goal is going to be similar. I want to get 1s on the diagonal and 0s everywhere else. I want to get the first column, I want to be, 1, 0, 0. The second column, I want it to be 0, 1, 0. So it looks a little bit different, but let's just give it a try and see what happens. So let's see. I'm going to first start with that first column. All right, and I want a 1 followed by zeros in the columns below. So I think I'm just going to use row 1 to then zero out the columns below it. Or the zero out the rows in that same column below it. So I'm going to take row 2 and I'm going to subtract row 1. That seems like an easy thing to do. So I'm leaving row 1 as it is, and then I'm subtracting row 1 from row 2. So we get 0, and then negative 2 minus 2 becomes a minus 4. 0 minus 4 becomes a minus 4. Okay. And then I might as well just go ahead and take care of the third row as well. So I can take row 3 and subtract 4 times row 1. So let's see what we get there. I'm going to make little notes to myself. This becomes minus 4. This becomes minus 8. This becomes minus 16. Okay, when I multiply by negative 4. All right, so then 4 minus 4 is 0. 3 minus 8 is a negative 5. And then 12 minus 16 becomes a negative 4. All right, so now probably the easiest thing to do would just be to take a negative 1/4 of row 2. I'll just take that little baby step. So I'm not going to touch row 1, and I'm just going to divide this whole row by negative 4. So this becomes 1 and 1. And we'll just leave the third column, or the third row alone as well. And negative 4. Okay, so that was kind of an easy baby step. All right, so now I want to use the this 1 in the second column, right in the middle of the second column, to zero out the rows above and below it. Okay, so I'm going to take row 1 and I'm going to subtract 2 times row 2. All right, so let's see what that does. So 1 minus 0 is still 1. And then this becomes negative 2, right? So this becomes a 0. And then negative 2 plus 4 gives me a 2. Okay, I'm not going to touch the second row at all. I'm going to leave that as is. Okay. And then we're going to zero out the second column in the last row. So in this case, I'm going to take 5 times row 2. So let's write that down. I'm going to take row 3, and I'm going to add 5 times row 2. Okay, so this becomes 0, 5, 5 if I multiply by 5. So when I add those two rows together, I get 0, 0, and then 5 minus 4 is a 1. All right. All right, so what's this telling us? Let's just look at this. This is saying, the first row is saying that x is equal to 2. Second row is saying that y is equal to 1. And the last row is saying 0x plus 0y is equal to 1. All right, so what's going on there? You know, even if I do say x is equal to 2 and y is equal to 1, if I try, that solution does not satisfy this last equation, because this last equation can never be true. This is never true. Not true. Never, ever can 0 be equal to 1, right? So this last equation is not true, which then invalidates any other solution that we got, because even if x is 1 or x is 2 and y is 1, it still doesn't satisfy that last equation. So there's no solution that satisfies all three of those equations at the same time. So we say this is inconsistent, and that there's no solution. There's no solution. So that's our answer to this one, is that there is no solution to this set of equations. All right, so we got one more example to go through, and I'll meet you in the next video.